Today, we have a geometry challenge coming from one of our followers, and the question goes like this. Given this triangle ABC having an area of 60 square units, this segment AB, let's cut this into the ratio 1:2, and this segment BC, let's cut this into 3 equal pieces. Now, let's draw two segments inside our triangle. And now the question is, what is the area of this yellow triangle? Now, pause this video right now and see if you can answer this question, because I will show you the answer and the solutions in 3, 2, 1. Alright, the answer is 4 square units. So the area of this yellow triangle simply equal to 4 square units. Since the answer is 4, in this video, I will show you 4 different approaches to answer this question. So the first method is by using ratio of areas. The second is by using the Ceva's theorem and, of course, the ratio of areas. And the third one, Menelaus theorem with ratio of areas. And the fourth solution, an effortless solution using mass point geometry. Let's begin with our first solution using ratio of areas. Alright, so what is ratio of areas? If we're given two triangles having the same height, then the ratio of their areas must be equal to the ratio of their bases, or vice versa. If we have two triangles having the same base, then the ratio of their areas must be equal to the ratio of their heights. So to start with, let X be the area of this yellow triangle. From this intersection, let's connect this to point B. We have two triangles having the same base and the same height. Therefore, we can say that they have the same area. So this triangle is also equal to X square units. And now what we're going to do is from this vertex A, let's connect this to this point right over here. And then notice these three triangles. These three triangles having the same height and the same base. Therefore, they have all the same area. Since the area of the whole triangle ABC is 60 square units, therefore each triangle having an area of 20 square units. So this is 20 square units, and this triangle right over here is also 20 square units. But we have here X square units. Therefore, this blue triangle having an area of 20 minus X square units. Now from here, what we're going to do is to consider this triangle color in green. These two triangles having the same base, as you notice. So what we're going to do is to find out what is the ratio of their heights. And to do that, let's extend this segment right over here. Now, from vertex A and vertex B, let's draw their respective heights like this. Now, these two formed right triangle are said to be similar because we have here vertical angles. These two angles are alternate interior angle, and we have here 90 degrees. Therefore, using AAA similarity, these two formed right triangles are said to be similar to each other, since the hypotenuse of those triangles having a ratio of 1:2, therefore their heights must have the same ratio. So let's call the first one H and the other one is 2H, or still 1:2. Now, using the ratio of areas again, since they have the same base, therefore we can say that the ratio of their areas must be the same thing as the ratio of their heights. So 2x over 20 minus x equals h over 2h. Simplify, this will give us 1:2. As expected, now let's find out the value of x. Cross multiply, this will give us 4x equals 20 minus x. Add x on both sides, we have 5x equals 20. Divide both sides by 5, we get that x equals 4. And that is the area of this yellow triangle. And that is the answer to this question using ratio of areas. So using the first method, we get that the area of this yellow triangle simply equal to 4 square units. Now, how about the Ceva's theorem? So let's begin. What is Ceva's theorem? So Ceva's theorem states that the product of the ratio of the side length divided by the concurrent segments of a triangle will be equal to 1. So, to use this Ceva's theorem, what we're going to do is to connect this point A to this point like this. And let's extend this segment from point B like this. Now, let's call these two equal segments as A. We have here 1 and 2, and this segment be equal to B, and this one is C. So using the Ceva's theorem, we can say that B over C times A over A times 1 over 2 simply equal to 1 because this point is the point of concurrency of these two Cevians. Now simplify, this will give us B over C equals 2. It follows that B equals 2 times C. In short, this B simply equal to 2 times C. So that their ratio must be equal to 1:2. From here, we will use again the ratio of areas. Now consider this base ratio 1:2. In short, we can say that the area of this must be the same ratio 1:2. So let's call this as n. This area must be equal to 2n. Now again, the base is 1:2, so their areas must be equal to 1:2 also. So let's call this as m, and this one is 2m. Now, let's have their base ratio be equal to each other, A:A. Now consider this big triangle, so we can say that the area of this triangle must be equal to the area of the other one. So 3m plus x simply equal to 3n plus x. Simplify, we can get that m equals n. In short, we can replace those n with m like this. And now, using again the ratio of areas, we have here two triangles having the same height. Therefore, we can say that the ratio of their areas must be equal to the ratio of their bases. So, 2x plus m over 5m simply equal to 1:2. Now, let's solve for the value of x in terms of m. So, we have 4x plus 2m equals 5m. Subtract 2m on both sides. So, we have 4x equals to 3m. And now, let's set aside this result. And take note, the area of this blue triangle simply equal to 20 square units a while ago. So, we can say that 3m plus x equals 20. We know the value of 3m is 4x. So, we have 4x plus x equals 20. We have 5x equals 20. Divide both sides by 5. We get, again, x equals 4. In short, the area of this yellow triangle simply equal to 4 square units. So, we have here the Ceva's theorem. Now, using two different solutions, we get that the yellow triangle simply equal to 4 square units. Now, how about the third solution? Using the Menelaus theorem. So, we use a lot of Menelaus theorem in our video. So, maybe you are familiar with this theorem. So, to use this theorem properly, what we're going to do is to rename our vertices. So, let's call this vertex as A. This will be vertex B. This is vertex C. This is D, E, and F. Now, let's call also these equal segments be equal to A and A. This is 1:2. And this segment, BE, is B, and EC as C. Now, using the Menelaus theorem, we have this format. So we have AF over CF times CE over EB times BD over DA. So we have 2A over A times C over B times 2 over 1 equals 1. Simplify, A over A is 1. Now simplify again, multiply the numerator and the denominator. We have 4C over B equals 1. It follows that B equals 4 times C. In short, this B, we can replace this as with 4C. Now, let's connect this B and F. And we know the area of this triangle BEF. A while ago, we have here 20 minus x square units. So again, using our friend ratio of areas, these two triangles, yellow and blue, having the same height, Therefore, the ratio of their areas must be equal to the ratio of their bases. So we have x over 20 minus x equals c over 4 over c. Simplify, this will give us 1 is to 4. Now, we are now ready to solve for the value of x. Cross multiply, we have here 4x equals 20 minus x. Add x on both sides, then divide both sides by 5. Again, we get that the value of x simply equal to 4 square units. So using the Menelaus theorem, we get also that the area of this yellow triangle is also equal to 4 square units. Now, let's have the effortless solution using the mass point geometry. And this is one of my favorite technique in geometry. So let's begin. So how this mass point geometry works. So given this example, we set mass to every vertex of a triangle. So for example, this P is 9 kg, this R is 5 kg. Therefore, the mass of this vertex T is the sum of P and R, which is 14 kilograms. And we can say also that the ratio of PT to TR is simply equal to 5 is to 9. So using this concept, we can now answer this question. So first, let's connect this A and this vertex. Now we can set the mass for A. This is just 1. And this B, this is just 2. And the mass of this point between A and B must be equal to 2 plus 1 or simply equal to 3. Now since these two segments are the same thing, the mass of this point right over here must be equal to 2 also. And the mass of the point between them must be equal to 2 plus 2 or simply equal to 4. Now, these two segments having a mass of 2 and 2. The mass of this point between 1 and 4 must be equal to 1 plus 4 simply equal to 5. Now, the ratio of these segments must be equal to 1 is to 4. Now, let x be the area of this yellow triangle. Also, we know the area of this blue triangle, we have 20 minus x. And again, we will use what we call the ratio of areas. So these two triangles having the same height, therefore the ratio of their areas must be equal to the ratio of their bases. So x over 20 minus x simply equal to 1 is to 4. Again, solve for the value of x, and sure enough, we get that x simply equal to 4 square units. And that is our answer to this question using mass point geometry. So, using 4 different methods, ratio of areas, Ceva's theorem, Menelaus theorem, and the mass point geometry, we get that the area of this yellow triangle simply equal to 4 square units. And as always, we are done.